everyone, welcome back to Shiva EduWorld.
In this video, I'll discuss about speech and video processing. I have already explained the Unit 1 important questions along with the key answers, and here is the Unit 2 video. Here, if you watch this video till then, for sure you can pass easily and score high marks. Clear? You can easily score 90% from this Unit 2 easily. So before starting, if you are new to Shiva EduWorld, then subscribe to it for more videos like this, and comment below if you want me to explain any particular subject or topic. Let's get into the video. Here I have already explained this Unit 1 video. Go and check out that first. After that, come to this video. This is completely about speech recognition, which means the features of extraction for the speech, static and dynamic features of the speech recognition, MFCC, LPCC, these meanings, everything completely about the speech recognition. This is the complete syllabus of Unit 2 in speech and video processing. Here I have prepared 9 questions in such a way that it will cover the complete syllabus of this Unit 2, which is very simple and easy unit compared to other. Let's get into the video. The first question is explain feature extraction for speech recognition. First, we have to explain why we need feature extraction. What is the need of this feature extraction? Here, raw speech is complex and very large. The raw speech, whatever is there, it is very complex and large, and it contains noise and unnecessary data. And the features captures the important information like frequency, pitch, and energy. That is why it makes recognition faster and accurate. That is why we need feature extraction. The raw speech is a complex and large. It has the noise and unnecessary data. To remove that, it will take only the important information like frequency, pitch, and the energy. So it makes recognition faster and accurate. That is why we need the feature extraction. Clear? Steps in feature extraction. What are all the steps we have? We have 5 steps here. You have to remember. Pre-emphasis, which means it will boost the high frequency signals and improves the clarity of the speech. This is the first step. And the second one is framing. Speech is divided into small. Why? Because speech changes over time. Third one is windowing. Apply window here like Hamming window. And the next step is it removes the signal discontinuities. And the next one is FFT, which means fast Fourier transform. It converts the signal from time domain to frequency domain. That is FFT. And the next step is feature calculation. It extracts the important features like MFCC and LPCC, energy and pitch. I'll explain in detail what is MFCC, LPCC in detail next question. And here the common features used are MFCC and LPCC. MFCC means Mel frequency septal coefficients, and LPCC means linear predictive septal coefficients. And spectral features, pitch and energy. These are all the common features used in this speech recognition. Clear? And the feature extraction is the process of converting speech signals into a set of meaningful features. That is why we are removing the unnecessary data, the noise and unnecessary data. And that represents the important characteristics for accurate speech recognition. Clear? This is what the feature extraction means. Clear? Let us move to the next question. What are static and dynamic features in speech recognition? Explain with example. Here, static features means these are the basic features extracted from a single frame of speech. Static means we have only single frame of speech. The basic features extracted from the single frame of the speech. And they represent the instantaneous properties of the signal. Clear? For example, MFCC coefficients and LPCC coefficients. Energy of the signal. I'll tell one simple thing here. What is happening at the moment in speech? This is a static feature. And the second one is dynamic feature. These show how speech changes over time. That is dynamic, which is not static. These two are opposite to each other and calculated using differences between the frames. How to calculate means the difference between one frame to another frame. That is dynamic features. Delta features we have here. Delta and delta, that is delta square. We have 2 types here. Delta and delta square. First order derivative, that is delta, and second order derivative is the delta square. You can also mention these two and write down. For example, for dynamic features, change in MFCC over time. The change, dynamic means the change in MFCC over time, and change in energy or pitch. Here, how speech is changing over time. This is the example for the dynamic feature. Let us move to the difference here. Static is from single frame. I have told you already. The basic features extracted from the single frame. And here dynamic from multiple frames. This happens between the multiple frames, and no time variation. Here the time variation is not there. It shows the time variation. Clear? It is very simple compared to dynamic. It is more informative compared to static. Here static features represents the current characteristics of speech, while dynamic features captures the temporal changes in speech, improving the recognition accuracy. Clear? This is the static focuses on the characteristics of the speech, where the dynamic focus on the changes in speech and improving the recognition accuracy. Clear? Let us move to the third question. Explain MFCC, which is very important question, which means Mel frequency septal coefficients in detail. You have to first write down the abbreviation for this, and this is the most widely used feature extraction technique. Clear? And in, where we use this technique means in speech recognition. It represents how human can hear sound by converting speech into Mel scale frequency features. This is what MFCC means. And why MFCC is used? Humans ear doesn't hear frequencies linearly. Clear? And MFCC uses the MEL scale, that is human hearing scale. MFCC uses that MEL scale and it gives high accuracy in speech recognition. And we have some steps in MFCC: pre-emphasis, framing, windowing, FFT, MEL filter bank, and logarithm DCT. These are all the steps involved in this MFCC. The first one is pre-emphasis. It boosts the high frequencies. And the second one is framing, dividing speech into small frames. I have already told you about. Third one is windowing. Apply Hamming window to smooth edges. And fourth one is FFT, fast Fourier transform. It converts the time domain to the frequency domain. And the fifth one is MEL filter bank. It applies triangular filters on MEL scale, that is MEL filter bank, and it captures how you perceive the sound. This is how MEL filter bank works. Sixth one is logarithm. It takes log of the energies and mimics human loudness perception. And DCT, discrete cosine transform. It converts the data into compact form, and the final output will be MFCC coefficients. Clear? This is how the MFCC works. Let us see the block diagram of this MFCC. Speech undergoes the pre-emphasis, and after that framing has done, and windowing, FFT, MEL filter bank, after that logarithm, DCT, and MFCC. Here you can see MFCC coefficients is the final output here. Clear? Whatever the steps we have, you have to write down in a diagrammatic form. Clear? Here the advantages of this MFCC are: mimics human hearing by logarithm. After that, it reduces the noise impact. It gives the compact and efficient features. These are all the advantages. And what are the applications of this MFCC? Speech recognition, speaker recognition, voice assistant like Alexa and Siri. These are all the applications of this MFCC. Real world applications. Here, MFCC is a feature extraction technique that converts speech signals into MEL scale septal coefficient. Effectively represent human auditory perception for accurate speech recognition. Clear? This is all about the MFCC. And the fourth question is explain LPCC, which means linear predictive septal coefficients. Here, this is the feature of extraction technique used in speech recognition. I have already mentioned this earlier. That is based on linear predictive coding, that is LPC. And it represents the speech by estimating the vocal tract characteristics. Let us see. Speech is produced by the vocal tract system. Everyone knows this. And LPCC assumes the correct speech sample can be predicted from the past samples. By using the past samples, it will predict the current speech sample. Clear? And it models speech using a linear combination of previous samples. That is why the name itself says that linear predictive septal coefficients. And here predict current speech using the past speech. This is the best example for this LPCC. The steps involved in LPCC are pre-emphasis, framing, again same as the previous one. Pre-emphasis, boost the high frequencies, and framing, divide speech into small frames, again framing, windowing, apply window to smooth signal. LPC analysis, this is the separate one. Calculate the LPC coefficients using the past samples only. After that, septal conversion. It converts LPC to the whatever the LPC is there, it converts that to the septal coefficients. After that, these are called as LPCC. Here, this is the final output here. And the current sample is nearly equal to the weighted sum of previous samples, because based on the previous past samples only, it will assume the current speech sample. Clear? That's why both are slightly equal. And the advantages of this LPCC are efficient and simple, represents the vocal tract accuracy, it requires less computation as well. These are all the advantages. And disadvantages: sensitive to noise. Whenever the noise is high, then this acts as very sensitive. Less accurate than MFCC. This is the biggest disadvantage here. This is not accurate than the MFCC. Clear? And in real world conditions, applications where and all we use in real world: speech recognition, we use speaker identification and speech coding. These are all the applications of this LPCC. And LPCC feature extraction technique is it uses linear prediction to model speech and converts LPC coefficients into spectral coefficients. I already told you here, it converts LPC things to septal coefficients to represent the vocal tract information. Clear? This is all about the LPCC. Always remember, you have to write according to the marks given. Ask it for. Clear? Don't write pages for just 5 marks. Write according to the marks given. Compare MFCC and LPCC. Here, MFCC means MEL frequency septal coefficients. LPCC means linear predictive septal coefficients. This is based on human hearing, that is MEL scale. And LPCC is based on linear predictive coding. I have already told this LPC. You have to remember this LPC in LPCC. Here, it uses frequency perception of human ear. LPCC uses the prediction of current sample from the past samples. By using past samples, it will predict the current samples. I have told you. The accuracy is very high in MFCC. Here, it is moderate. And it is low compared to MFCC. And it is less sensitive to noise. Here, I have told in the disadvantages that this is more sensitive to the noise. This is more complex and high accuracy. This is simpler than the MFCC. Frequency domain. It represents the frequency domain. This will represent the time domain. Here, robustness is this is more robust in real environment. This is less robust, and it is widely used in modern systems. I have already told you. The applications of MFCC are speech recognition, speaker recognition, Alexa and Siri. That is why it is widely used in modern systems like Alexa and Siri. It is used in basic or older systems only, LPCC, because this is very simple and accuracy is very less and less robust. That is why it is used in basic and older systems. The applications, as I already told you, speech recognition, voice assistant like Alexa and Siri, speech coding and basic recognition. Clear? And the next question is what are distance measures in speech recognition? Explain different types. Here, these distance measures in speech recognitions are used to calculate the similarity between two speech features vectors. Those are MFCC and LPCC. They used to calculate the similarity between these two speech feature vectors. Clear? They help the system decide which word or the sample is closest to the input speech, which is closest to the input speech. For example, measures how similar two speech signals are. Clear? Why we need this distance measure means to compare input speech with stored patterns and to find the best match, that is MFCC or LPCC. It is used in classification and recognition as well. The types of distance measures are Euclidean distance, Mahalanobis distance and dynamic time wrapping. These are all the types of distance measure. Euclidean means the most common method is used here. This is the most common method used in the distance measures, and it measures straight line distance between two vectors. For example, if distance is small, signals are very simple. This is Euclidean distance. And Manhattan distance means the sum of absolute difference. What is the difference is the sum of the absolute difference, and it also called as city block distance. For example, it adds differences instead of squaring. Here, the sum of absolute differences. And Mahalanobis distance means it considers correlation between the features, more accurate than the Euclidean distance. It is used when features are related together. And dynamic time wrapping, DTW, means it handles the different speaking speeds. It aligns two speech sequences over time. It is very important for speech recognition. That is dynamic time wrapping. Here, small distance is high similarity, large distance is there means then low similarity. If the distance is very small, then high similarity is there. Large distance is there means the similarity is very low. Clear? Let us move to the next question. Explain vector quantization VQ model in speech recognition. We have to explain VQ, vector quantization model. Here, this is a technique used to compress and represent the speech features efficiently by grouping similar features vectors into clusters, which means here vector quantization is nothing but it is a technique to compress. It will compress and represent the speech features efficiently without losing any data, and by grouping similar feature vectors into a cluster. Clear? How they will compress means it will group together similar feature vectors into a cluster. Clear? For example, convert many speech vectors into a few representative vectors. This is how this vector quantization will happen. The basic idea I'll tell. Speech features like MFCC produce many vectors, right? Here VQ reduces them into a small set of representative vectors, and this set is called as code book. Whatever it has reduced them into a small set of representative vectors, that set is called as code book. Clear? You have to write everything. And working of VQ. How exactly this vector quantization will work? Here, feature extraction. It will extract the features of MFCC and LPCC. After that, grouping similar vectors using the algorithms like K-means clustering. Clear? Clustering algorithm it will use, and it will group the similarities of the vectors using the K-means clustering algorithm. And codebook generation. Here, each cluster is represented by codebook, as I already told you here. And matching. Input speech is compared with the stored codebooks. What are the input speech that is stored, that is compared to this codebook. And minimum distance is there means that is best match. Clear? And we have a diagram that you have to explain. Speech, after that feature extraction. The speech is undergoes the feature extraction. After that, clustering, codebook, matching and recognition. This one you have to write down like a block diagram. Clear? You have to write down in a box and write this flow. Write down this flow. The advantages of this vector quantization are it reduces the data size because we are compressing the data. Here I told you, right? It will compress the data. Correct, right? And fast processing. When we compress the data, processing will happen fastly, quickly. Simple implementation is also there. As I told you here, this is the implementation working process of this VQ. This is very simple. And disadvantages, loss of some information while compressing the speech. it may lose some data, some information. This is the biggest disadvantage. Less accurate than advanced methods. We have advanced methods like GMM and HMM. This is less accurate than these advanced models. Clear? These are all two disadvantages. And applications in real world, where and all we use the vector quantization, means speech recognition and speaker identification. Here, VQ is a technique that compresses speech features vectors into codebook and representative vectors. It enables the efficient and faster speech recognition. Clear? This is all about the vector quantization. And the 8th question is explain Gaussian mixture model, that is GMM. I have told you, right? GM and HMM, these are all the advanced models. Clear? This is accurate as well. GMM is very accurate compared to the vector quantization. Let us see Gaussian mixture model. Here, this is a model used to represent the distribution of speech features like MFCC. This is used to represent the distribution of that speech features using combination of multiple Gaussian distributions. Let us see, for example, the model speech data as a mixture of many bell-shaped curves. If I explain these things with the basic concept and how it will work, then you can easily understand. Here, speech features are complex and cannot be represented by single distribution. This is very complex, right? The speech features are very complex and cannot be able to represent in a single distribution. GMM uses multiple Gaussian components. That's why it makes very simple. And each Gaussian represents a cluster of similar speech data, which makes efficient and simple as well. Working of GMM, how it will work? Feature extraction again. It extracts the features like MFCC. After that, modeling. It assumes the data is generated from multiple Gaussian distributions. Modeling. And parameter estimates. How to calculate means we have mean, variance and weight. These are all the parameters to calculate this Gaussian mixture model. Matching, it computes a probability of input belonging to model, which means it will compute the probability of that input belonging to model, and the highest probability means recognized speech. This is the output. This is how exactly the GMM will work. Here, each Gaussian is one pattern in speech. Combination of that means complete speech model. Clear? We have combination of that Gaussian. The advantages are flexible and powerful, model complex data well. It models the complex data well and better than VQ, as I already told you. The disadvantage is also there. It is computationally expensive because it handles the complex data into a systematic way. That's why it needs more training data and computationally very expensive. These are all the disadvantages. Applications are speech recognition and speaker recognition as same as the VQ and all. GMM is a probabilistic model that represents the speech features as a mixture of multiple Gaussian distribution to accurately model the complex speech patterns. This is how exactly this Gaussian mixture model works. And the last question from this unit 2 is explain hidden Markov model, that is HMM, with need diagram and applications. Here, this is also a statistical model used to represent speech as a sequence of states. That you have to remember the difference between HMM and this GMM. Clear? This is a static model. It is used to represent the speech as a sequence of states, where the actual states are hidden. The actual states are hidden here, but we can observe the outputs. Clear? For example, we can see the output, but internal state is hidden. We can see the output. Internally, whatever is happening, the internal states, everything is hidden. The speech changes over time, and that comes to the sequential data. Here I have told you that the states are hidden, the internally whatever is happening, it's hidden, and the observation, that is visible. The outputs are visible. The components of HMM, we have states, observation, transition probability, emission probability, and initial probability. States are hidden, as I already told you. It represents the different speech. And the second one is observations. The features like the feature vectors like MFCC and LPCC, which we can see. The output, we can say that observation is the output, MFCC and LPCC. And transition probability of moving from one state to another state, that is transition probability. And emission probability means the probability of observation from a state, that is emission probability. And initial probability, starting state probability. This is initial probability. These are all the components of HMM that you have to mention and write down. Here, if you see the diagram, state 1, state 2 and state 3, these are all the states which are hidden, and the output we can easily see. Working of HMM, it extracts the features from speech and model speech as a sequence of states. After that, calculate the probabilities, find the most likely state sequence. After that, recognize the speech. This is how exactly the HMM works, and the advantages are it handles the time variation in speech. That is the most biggest advantage, and very accurate compared to VQ. Widely used in real systems. Applications where and all we use is HMM means speech recognition. Google Voice, Alexa and Siri. Handwriting recognition also we can use. Bioinformation. There also we use this HMM. Here completes the unit 2 of speech and video processing. If you found this video even 1% helpful, then subscribe to Shiva EduWorld, like this video, share this video with your friends. Exams are very near. And if you want me to explain any particular subject or topic, comment below and let me know. For sure, I'll consider that. And if you want this PDF notes, I'll comment in the comment section that I'll just give the a link of this PDF notes. Just by clicking that, you can easily access the notes as well. Thank you very much for watching. See you in the next video.